In this video, we're going to make a laser bumper robot. All of the resources that you need are at jb.works, and at the search prompt, simply enter the TMT code shown on your screen and press enter. And this will take you to the page that has this video and also other resources like how to connect the motors, etc. In this video, we can see the bumper robot in action. So as it approaches an object, it turns to the left to try and avoid it. And by doing this, it's able to navigate its way around this room, which is actually a classroom. And so when it sees something, it stops, it turns, and then it carries on. It keeps on going until it sees something else. And then it turns to avoid it. So this is an obstacle avoiding robot. And it's using the laser rangefinder in the front to avoid obstacles in its way. As you saw in the video, this is basically a normal driving robot with wheels and so forth, and a laser rangefinder in the front. And as you also would have seen, when it approaches an object, it will stop, back off, and then turn, and then carry on going forward. And the key is the laser rangefinder, which is this one here. And what it's doing is measuring the distance the robot is away from objects. And then when it detects that the object is, say, closer than 3/4 of a meter or 750 millimeters, it'll stop, go back a wee bit, and then turn. Or it will turn and go back. So it wants to get away from the object so that it can then carry on in its path. So now that we know how it works, let's see what we need to build it. To build this robot, you're going to need a already built JackBord with the drive motors attached. The information that you need is in a video on the jb.works website, and at the search prompt just enter the TMT code on the bottom right of the screen, and that will take you to the video that shows you how to attach the drive motors. The next thing you're going to need are two female jumper wires that are about 20 centimeters long, roundabout, and two short female jumper wires, a laser rangefinder module, two M4 bolts, two M4 nuts, a piece of jackknife, which is a right angle bracket, a spanner, and an Allen key. Putting it together is really easy. The main thing we do first of all is we want to put this bracket onto the front of the JackBord because that will hold the sensor. So to do that, we take one bolt and just put it through the middle hole there. And then using the hole, because this guy has an oval there and a hole, so we're just going to put the hole side in here, and we'll put a nut on to anchor that in place. And we're doing all of this so that we can mount the sensor, and I'll show you in a minute, so that it can detect objects. And you want to make sure that this is basically parallel with the front of the robot. So this is the laser rangefinder, and this is the sensor, so it needs to face out towards the front. So basically take a bolt and put it through the bracket like so, and then just angle it up, and while holding it in with your finger, put in the sensor like that. And then we just put a nut to hold it in place like so. And of course the drive motors were already put on, and you just refer to the previous video for how to do that. So now we've got the ultrasonic sensor mounted on the front. So what we're going to do next is connect the power. So first we'll take the short green jumper wire. You can use a different one, but green is good for ground. And this is going to go into the ground pin on port B. And then this sensor, because we've got a yellow pin here, that's telling us that it needs 3 volts. So we use a yellow jumper wire, go there, and into the 3 volt pin on port B. Now this sensor here uses I2C, which is a serial protocol for communication. And the I2C port on the JackBord is over here. So we need to get the signals from here over to here. So this is where we use the long jumpers. So I'm going to take my first white jumper wire, and notice it goes into the white pin on the sensor. And that goes to port pin D5 on the JackBord. And that's the SDA pin. That's serial data. Then the next wire is a blue one, which we put onto the blue pin on the sensor, and that's the serial clock, and that goes into the SCL pin here on the JackBord. So now essentially that's our completed robot. That's all the construction done. So we've mounted the sensor on the front so that it can see in the direction that the robot will be driving. We've got our power lines and we've got our data lines for the sensor to communicate. Okay, in this series of pictures, you can use these to check that you've got your construction correct. So this is an overall picture. This next one shows you the mounting of the right angle bracket. And this is where the sensor will eventually go. And so here we've got the sensor, and notice the nuts and bolts at the bottom holding it in place. Particularly note that the nut of the bolt that attaches the sensor to the angle plate is on the front of the robot. This makes it much easier accessing it with the spanner. These two pictures show the connection of the 3-volt power supply to the sensor. So note that the sensor needs 3 volts and we're using the 3-volt pin on port B of the JackBord. And of course the ground pin is green. And here on the left we see the data connections from the I2C port to the sensor, and then on the right we see the corresponding connections on port D of the JackBord. And then finally we have the completed robot showing all of the wiring. So check what you've done against these just to make sure that everything's as it should be. And if you don't have the exact same colors of jumper wires that I've used here, that's fine. Just make sure they go to the right places. Okay, so now that everything's connected, we need to turn on the JackBord. Let's push the power button. Now that we've got the robot built and we're at the dashboard, we need to get the program code that will actually make it work. To do this, visit jb.works and enter the TMT code shown at the search prompt and press enter. This will take you straight to the program listing. So to get the program code, go to jb.works and at the search prompt, paste in the TMT code and press enter. And this will take us straight to the code. So then all you do is just put the mouse somewhere in the code itself and press Command A, or if you're on a Windows PC, Control A to select it all, and then Command C or Control C if you're on a Windows machine to copy it. And then we go over to the program page. I'm on slot 1. I'm just going to select all this and delete it. Then I'm going to paste in the program code and click on Save. So now we have the program code in slot number 1 ready to run. Okay, so we've got the program code, so let's have a quick look at that and then we will just run it and see how it goes. So essentially we've got a variable here that holds the distance, and that's that. And then here at program start, that's where we're setting everything up. We clear the screen, we find the sensor on the I2C bus, and then we just display a title and we wait 2 seconds just to let things settle down. If we're debugging, we can display the distance here, but we're not going to. Now this is the first part. Now inside the JackBord there's a system variable called s_ldist, and that's this one here. Because it's a system variable, it basically means that it's built into the JackBord and it's always there. So when the JackBord detects that a laser rangefinder has been attached, it will from that point on automatically put the distance readings from that sensor into this system variable. And so what we've got here is an any statement, and what we're basically saying is if the distance away from the object in front of us is less than 750 millimeters, then we've bumped into something. So we show bump and the distance. Then we go backwards at half speed, and we do that for 1/4 of a second. So that gets us away from the object. Then the next thing we do is we do a left-hand turn, and that's essentially by making the left-hand motor go backwards and the right-hand motor go forwards, both at half speed. And we do this for 1/4 of a second. And then we loop down here. Now if we're here, it means the distance was less than 750. We then come down here and we're checking to see if the distance is more than 600. And if it is, we think we've got away from the object. So we basically just start going forward at half speed. And finally, we just have a wee 100 millisecond delay down here so we don't go nuts. And then we move straight up to the top of the loop and we just repeat this whole process over and over again. So if I run the program now, I've got the robot jacked up because I don't want it running around the table while I'm doing it, and I put tape on the wheels so you can see which direction they're turning in. So let's run it. So there's the message, and here are the readings. So you can see that both of the wheels are going forwards because if you look at the display here, we're free, there's nothing that's closer than 750 millimeters. But now if I put my hand in front, you see how the left hand wheel here is going backwards, that one, and then the right hand wheel is going forwards. And also you see how it's saying bump on the screen, so right here, it's saying bump. So as I move my hand further and further away, the distances get greater, and eventually it's going to reach a point whereby it's happy, and now both wheels are going forward. And it will just keep on doing that until another object comes in the way, and then it goes back and does a turn. So if I just quickly disturb it, it goes back quickly and goes forward straight away pretty much. So it reacts pretty quick. And this is the laser bumper robot. And finally, to stop the program, we want to run the prog stop function, task rather. And that will print by, and then it will stop the motor. So if I click on stop on the program page, see, it says goodbye, and the motors have stopped. Now this is program number 2, and again, to get the code, just go to jb.works and enter the TMT code shown on the screen at the search prompt, and you'll be taken straight to the code. Right, this is the second laser robot program, and what we've basically done is kept everything the same, except we now have a variable that holds the speed for the left motor and a variable that holds the speed for the right motor. So the rest of the setup is the same, but when we get down to here, if we collide with something, just like before we move back, which is fine, but now we use a random speed to control the left motor and another random speed to control the right motor. So the turn that the robot does when it detects an object is going to be different and random. And what this code here is doing, so rand 75 to 100 basically says generate a random number between 75 and 100 and then store it in the left speed variable. And likewise, rand 50 to 75 generates a random number between 50 and 75 and stores it in the right speed variable. Now the reason we use 75 to 100 for the left motor is that I want to always do a left-hand turn, and I can guarantee that by making sure that the random numbers that the left motor gets will always be higher than those that the right motor gets, because the right motor can only get between 50 and 75. And then down here, because the random number function generates positive random numbers, I need to make the left motor speed negative. And so I'm just using the multiplier command to multiply -1 times the left speed, and that gives me a negative value. And then we use the set both motor speed command, we supply it with the left speed and the right speed, and then we print bump like before, but now we've added on the speed values that it uses. And everything else is basically the same. So if we run the program, you can see what it does. So again, it's setting up, nothing in the way. So if I introduce something in the way, you can see the speed readings on the right hand side. So if I just put my hand there, so here, see how they're random? So each time it detects a bump, it's using a different random speed. And this is quite good because if it gets stuck in a corner whereby if it uses the same speeds all the time, it'll just go back into the same problem, that's not very effective. And again, if I do a quick block, see it chooses 79 to 70. So now if I do a quick break, you can see the motor speed changes. I'll do it again. So the speed is 93 for the left motor, now it's 100 for the left motor. So you can see you're getting random values each time. And this makes the handling of obstacles and so forth a lot better. For more information and more projects, go to jb.works.